Hello, everybody, and welcome to the Microsoft Data and AI South Florida user group. My name's Adriano, your host. And before we get started, just a couple things. First, let us know whether you can hear us well using the live chat and you can see what material is being shared. Also, let us know where are you located. I have seen some couple of people here that are frequent here. Pablo, welcome, Pablo. And Jim, welcome, Jim. Thanks for joining us here. All right. And Safia, welcome, Safia. Thank you. Thank you. From Montreal, Canada. All right. Thank you. All right, folks. Today we have a very special presentation, as always, where we are going to be bringing here some amazing speakers. And we are going to be talking about SQL Server, Azure SQL, but the main part is really the query store. How can we make your life easier to do your maintenance management and improve performance? And for that, we have this amazing speaker, Deepthi Goguri, who is also an organizer to our user group. So very honorable, and she's an amazing speaker. Yes, I'm biased, but you will see for yourself. And in the meantime, before we get started and during the presentation, if you have any questions, feel free to use the live chat to enter your questions. I'll relay the questions to the speaker, and during the presentation, we will address your questions. Now, if you're watching this presentation and it has already completed, we will use the comment section below and we will comment on any questions you have, but also give a like and drop a comment to say that you like the presentation. So support the user group and support the community here on YouTube. All right, folks. Now, without further ado, let's bring here Deepthi. Hello, Deepthi. Thanks for
Hello,
joining us.
Adriano. How are you?
Oh, well, thank you. How about you?
I'm doing good. Yeah, busy day today. I'm on
I
call
am.
as well, so yeah, I
All right.
love to see the people showing up here. Yay!
Absolutely. Yeah, we have here, as I mentioned, Sophia, Jim,
Hello,
as
everyone.
well as Pablo.
Pablo.
Pablo as well.
hmm
And folks, if you're out there, say hello, use the live chat. Remember to subscribe to the group. So I see and thank you very much for making the time in your schedule, in your busy schedule here, Deepthi,
hmm
to be here with us. Really appreciate that. I know it's your lunch time and everything, so
Oh, well, it's our user group. That's the first thing. Thank you.
awesome.
I'm so honored to be here. I think people are waiting already to get started because we are like a couple of minutes late. So let's get started then.
Absolutely. Let's get started. So, folks, remember, drop a like, comment, and it's all you, Deepthi.
Thank you. Um, do I need to
Let's see.
add to stage my
Yeah,
screen?
yeah, I can see your screen. All
Okay.
right.
Just let me know once you were able to see my screen.
All right.
Um,
Yes, we can.
awesome. So, hello everyone. Welcome to Microsoft Data and AI South Florida user group. Adriano and I, we both manage this user group. Most part of it, Adriano take care of the presentations, like hosting the presentations, and I do the back end work with Adriano, but I'm trying to be as a host as well, as much as I can. So today I am going to be as a speaker on this stage in our user group. So hopefully you like this topic. So today I would like to go ahead and discuss on Query Store, and also mostly like what are the new advancements of Query Store. Like if you are new to this feature, this will be a very deep dive session for you. And if you're already using Query Store, you will be learning a lot of new content today. So let's get started. Without further ado, I would not waste my time by you talking. through this slide, but just all the contact details are here. And you can, if you have any problem in asking questions here on this platform, you can definitely contact me on Twitter as well as LinkedIn. I'm very active on LinkedIn, so it will be an honor to get in touch with you. So yeah. Um, so before beginning, I would like to share a story with you, which recently happened on my on call. Currently, I'm on my on call as well. So what was the incident, right? So I got a pager to my phone at the middle of the night, somewhere around like 2 a.m. in the morning, um, with a ticket with an critical incident ticket created on my name because I'm on call, and the incident details looks like this. Like a SQL Server view is taking forever to run and failed finally. Several months ago, Deepthi did something using Query Store to fix the issue. The issue was resolved then and then reoccurred again now. Could you implement the same steps to fix the issue? So I read this one at 2 a.m. in the morning. I am totally in sleep. I didn't even read that properly, and I was like, "Wait, what did I fix? When did I fix? And how did I fix?" All sort of questions. 2 a.m. in the morning, right? So I was like, I don't even remember I fixed this issue. Right? It's been several months ago, and they just mentioned the view name, database name, and server name. I just went ahead and saw the view. I didn't remember anything. So the first step that I went and I searched in my inbox to find that view based upon that view. So I filtered and I finally found out that I did something many months ago in the last year. So currently I don't know the issue at that time, but currently the issue in the instant was like this. The query processor run out of like internal resources and could not produce a query plan. So this is something like query engine is suffering, like it couldn't generate a plan. That means like the error itself says something related to the query itself. Like query might be terrible and the engine couldn't create a query plan for that view, right? So it can be the view, it can be the data, we don't know yet. So this was the issue that I need to fix now at 2 a.m. in the morning. All the information that I have is view and then database and server name. That's all I have. So I was like, oh, well, did I fix the issue? I did fix the issue a year ago, but then when and how? For a moment, I got a ego boost that I fixed something related to performance, but then it went again into the same stage of like we are seeing the issue, right? So we need to know what happened. So what I did to find out. I tried to dig into the details through my emails to find out based on the index, like the view name and the server name. I found something, but then as a resolution at that time to fix the issue, I just created an index with the help of the query store. So basically, we had this query store feature on the database where this view is running, right? So I just went ahead and I filtered out the queries. I used the query store views where I can filter based upon the query and based upon the view. So I filtered that view to find the query ID and then I searched for that query ID in the query store to get more details. So at that time, it recommended create an index within that query store window. That actual plan showed like create index recommendation. So I just took that and I saw if it really makes sense to create the index. And at the time, yes, it is, and that fixed the problem. But this time, the error is totally different. The last time it was a different error. This time it's completely different error. So when I fixed that issue a couple of months ago, why did it cause the performance issue again, right? So I was like, in that morning, I was thinking about different things. Did something change? And to the luck that developer who wrote this code is also online at 2 a.m. in the morning because this is a production view and it runs vigorously. Like several times in a day, and it even runs in the middle of the night. So he was online, he was looking around to fix the issue. So I asked him, like, did something change? Did you make any change to this? And did the query inside that view changed, or like he mentioned like he checked the view and everything looks as exactly the same. And then I thought, like, let me dig into the query store, and I filtered again on the by using the query store views. I dig in by filtering upon the view name and the like the query text to figure out that query ID and all sort of things. So finally, what I did, right? I use the query store view to find the query ID of that view, and then check the query and actually found that it is an ad hoc query that they are running from the application. This is not something, this is not a store procedure to just create a same query ID, but it is being run from the application. So whenever it runs, they are inserting different values in the where clause. So that is actually causing the problem, because every time it runs, it creates a new query ID, and that is a problem, but that is not the exact problem why we have seen that error message. The error message is caused by this: they explicitly included an extremely large number of values in the in clause where they are searching. So if you scroll down and see the view, right, the ad hoc view that they were running, it's like, if you print that view that they are running, it will be like this many pages, meaning like they are searching almost every value. So I thought, like, let me go ahead and select this view in total and see how many rows we have in that view. And completely in that view, we have just like 28,000 rows. That's all it is. And when I searched, when I searched the in clause, we almost have 28,000. So why should we even use that in clause when we wanted to get almost all the data, right? We can just do select star. So I was like, oh my God, why did I didn't see this issue several months ago? I just went ahead and saw, like, created the index and I thought it worked fine. But then the important thing is to completely figure out the issue within the code, right? We need to check the code, no matter even if you are creating the index, just see if the code looks proper and fine. So that was the problem. So engine thought, like, this is a query which I really didn't like, and look at the in clause, and it's a performance killer. So that's why it throwed an error saying, like, I just can't create a plan for this. So what I did was, like, I finally gave couple of workarounds. So I asked them to either select a subquery within an in clause, or, because in clause they are not using one or two values in the in clause. If you are using one or two values in the in clause and searching on it, then select subquery will work fine. But almost everything they are pulling it off. So I told them, like, just pull the entire table into the memory, and I requested them to put that into the console app server memory. So they did that, and just like that, the problem got resolved. You know, um, and this was totally, like, I was able to resolve this. I and the developer and I, we both were able to resolve this just because we enabled the query store on the top of that database. Just imagine if I didn't have the query store on, I would not have been able to see the plan. And from that plan, I I was able to see plan is like too huge, and it says like the previous plans, right? Right now it throwed an error saying like I couldn't generate the plan, but there were some previous plans to it. So when I checked that, I got, this is something weird, and then I went ahead and checked the query of the view, and that's how I realized what's going on within the view. So enabling the query store, having the query store in handy to see the past execution plans really helped me to fix that issue in the middle of the night, with taking the help of the developer. We totally fix the issue. Until now, this happened like couple of weeks ago, the last on-call incident that I had. I never have seen them contacting me again. This is totally fixed now. So how the query store actually helped me? It helped me through identify the query quickly, and we can also see like top resource consuming query list. Definitely this query was on the list, and it initially helped me to give the index suggestion, and I could able to find it is an ad hoc query. And with the ad hoc query, we cannot force the plan because query ID always gets changed. So if you are using Query Store, one of the advantage is to force a plan, but you can't actually force a plan here because it's an ad hoc query. And then we are searching on several different values, which will create an entirely new query ID. So it's not possible here. But I was able to see the entire query and its plan within the query store to make my decisions and to make my decisions very quickly, right? We were able to fix the problem within 2 hours. We actually changed the entire code. I mean, changing the code is really simple in my case, but just imagine if it is a complex code, you only have couple of hours to fix. By using the query store, you can actually force the plan if you do not have that time, and if you have to get some approvals from your management to change to touch the code, then by using the query store you can immediately fix the plan. If you are using, like, for example, store procedure, the query ID remains the same for the store procedure no matter what parameter you use. In that case, you can take the advantage of forcing a plan. So what's the agenda for today? With my example, let's go ahead and see. If you are not familiar, you will going to see the query store fundamentals, and query store fundamentals also includes how the query store actually runs behind the scenes. So we are going to talk about the internals of query store, like how behind the scenes, how the engine actually work with your queries when query store is enabled. And we are also going to see the benefits of query store, advancements in SQL Server 2022, best practices, and some of the things that you should never forget while using query store. And then we are going to see a lot of demos. Let's talk about query store fundamentals, right? So query store got released in 2016. It's like a flight recorder where once you enable it on the database, it's a database level feature and not the server level. So when you got your SQL Server 2016 and above, except 2022, because if you have 2022 and if you're creating any new databases, that new databases will already have query store enabled on it because they made it as a default. But if you are in between 2016 to 2019, then you need to enable the query store at the database level. Once you enable it, it will go ahead and collect all your queries, execution stats information, um, usage metrics like the stats, CPU, memory, IO, and the execution plan itself, um, and all sort of like execution information along with the execution plans over time. It will collect over time and it will save over time, and it will be persisted. This data will be persisted until you choose when to clear out the data. So even if your SQL Server restarts, your plan cache will be gone, but the queries and query plans that got saved inside the query store remains. So it will be persisted upon the restarts, which is good. And this feature is enabled from SQL Server 2016 and later. On Azure SQL Database, it is by default enabled. On Azure SQL managed instance, it is available Azure Synapse Analyticals only on the dedicated SQL pool only. And since it is a database level feature and you cannot enable on the master or tempdb gets recreated all the time. Master db you can't enable, but you can enable on the other databases, other um, um, what are the other tables, msdb database, and um, the um, system databases. But then, like, I do not know any scenario why we have to enable it on there on MSDB. I mean, and then, um, yeah, let's see what type of data it collects once you enable the query store, right? It will collect all the DML statements such as select, insert, update, delete, merge, and bulk insert. All of these DML statements. But it does not collect the plans for DDL statements such as create index, drop index, alter index, those sort of things. But then it will collect the cumulative resource consumption. It can't collect the resource consumption for each and every execution, because if it collects for each and every execution, the query store space that you allocate while configuring, it will blow up very quickly. So it will collect the data over time, and it will give you the cumulative resource consumption based upon the intervals that you choose. Now let's see how the query store actually works behind the scenes. Now this diagram might seem a little bit complicated, but let's make it simple. Let's say any query running on the SQL engine, the first thing that happens is engine will check if it is running for the first time or not. Now, if it is running for the first time, then it will go through the compilation and optimization phases, as you know, to build a execution plan. But if it is not running for the first time, and if it is running several times in a day, then it will go ahead and check whether the plan is already there in the plan cache. Now, if there is no plan in the cache, there might be several reasons why the plan will be kicked out of the plan cache. Sometimes you restart the server, and sometimes might be the memory pressure that might cause the plan to be out of the cache. In that scenario, then it will go through the compilation and optimization phases again to generate a new plan. And that plan will be saved in the cache again. But if it is in the cache, it will then all right, it will go ahead and take that plan from the cache. And the next step, right? Check for recompilation phase will happen when you force a plan by using the query store. Let's say you have forced a plan by using the query store, and now that query is running. Until now, what you have seen, that's a regular process with or without query store on, right? But with query store on, there will be an additional step that will happen, which is check for recompilation. In that recompilation, engine will check whether the plan that either been taken from the cache or the plan that is actually generated newly, because it is not available in the cache, it generated newly, whether that plan that got created or taken from the cache, is it similar to the forced plan? Because we are talking as an example the forced plan on a query, and that query is running right now. So it will go ahead and check if the plan that has been created, is it similar to the forced plan. Now, not every time it might be the same, it might be totally different because of several reasons. Um, because the index might have changed, somebody might have changed the index within that forced plan, and now the plan got newly created because it didn't find the similar plan as a forced plan. Now that index which was there in the forced plan, now it's not there, so it will generate a new plan, right? There might be several reasons. This is just one reason. But then um, if it is not that index that is newly created, if it is some other reason, then it will try and go ahead and recompile again to build a plan which is similar to the force plan. It will do that. But if it is similar to the force plan, then all right, it will go to the next step. But before going to the execution phase of the query, that particular query that is being run, the query text and the query plan of that particular query will be saved in the plan store. Now, where does this plan store comes in, right? So whenever you enable the query store on the database, there are some components in the memory will be enabled. And those components in the memory are the plan store, runtime stat store. And this is enabled in the memory. So inside the plan store, the query text and the query plan, both will be saved in the plan store. And this process will happen asynchronously and before the execution of the query. Now, after that is being saved, the query will goes to the execution phase. And inside the memory again, once the query executes, then it will go ahead and save the runtime stats. If you remember, the runtime stats are only available and gathered after the execution of the query. And that is the reason when you see the actual plan versus um, estimated plan, that is the difference. With the estimated plan, you will not get these runtime stats, but with the actual plan, you will get it with the runtime stats. But the plans that are saved inside the query store are always estimated plans. But as you know, we are collecting the runtime stats as well, right? The later. So this process happens asynchronously as well. And once everything is collected, there is particular interval that you can set on the query store for the collected data to be pushed into the query store schema. So by default, it is every 15 minutes. But if you have too much of workload, you can change that based upon your needs. Once that 15 minutes interval is reached, the collected data from the plan store and runtime stat store will be pushed to the query store schema, which is on the primary data file of the database. Now you can't change that location, right? It should always be saved in the primary data file. So this process happens asynchronously as well. Now, if there is a memory pressure on the server and the memory has to be released for certain queries to be run, in that scenario, this the 15-minute interval, even before reaching the 15-minute interval, the collected data in the memory can be pushed a little bit earlier than hitting the 15-minute interval, because again there is a pressure on the memory, right? That's the reason it have to push it as quickly as possible. That can happen. So that's how the query store, all the way starting from the query, how it executes, till the how the collected information will be saved inside the query store works. Now let's see couple of benefits. As we have seen how it works, now we wanted to see how what are the benefits if I enable, right? By enabling the query store, you have you can easily identify the difference between the execution plans. If it is working fine before, but now it is working worst, you can go ahead and compare those plans. You can see the regression between the plans. And then, if you do not have much time to fix the actual problem within the query, you can immediately go ahead and compare the plans, and then you can force the good plan so that the next time the query runs, the store procedure runs with no matter what parameter you use, it will go ahead and try to force that forced plan that you choose. So it is an optimally quickly fixable problem without changing the code. There are much more advanced features in query store as well, where you do not have to worry about looking like what query did I force. Now the forced plan that I forced, is it still good enough, or should I unforce and force a new plan? You do not have to worry about that. If you have an enterprise edition of SQL Server, you can take the advantage of automatic plan correction with Query Store. So we are going to talk about that as well. But that's one of the advantage, right? It will definitely help in performance tuning. Like my example, I have shown you how it worked for me. And most of the time, there can be no changes needed to the user applications or the underneath code. Again, in my case, we decided to go ahead and fix the problem permanently. That's the reason, like, we took the time, 2 hours of time to fix the problem, because in that case, I can't force a plan, right? It's an ad hoc query. But if you have store procedure and if you have to immediately fix the issue, you can force the plan. And also right side your screen, you can see there are underneath the query store, there are different set of reports that you can use. Each report you open, it will give the It will give the information based upon the report name. Regressed queries will give any regressions between the plans. You will see it in that particular report. In the same way, overall resource consumption, top resource consuming queries, and all the list of it you can clearly see in the graphical user interface with those reports. But also you can grab the same information through the query store views as well. Now scenarios for query tuning. There are some scenarios before going into the demo I would like to talk about. Like I have used I have used the query store not only to performance tune my queries to find the top resource consuming queries and then fix the problems quickly by forcing, unforcing, as well as using the automatic plan correction. But also, I used Query Store personally in my upgrade scenarios. Like we migrated several servers and databases from 2016 to 2019. So when we did that, we actually tried to migrate the database, but then still put the database in the old compatibility mode, which is 2016, and then collect all the query store information just like the way it used to collect in the old environment. I understand that our servers are new, but the databases is still in the old compatibility mode, which more or like more which more like it is similar to the way it used to be. So it gave us a platform where we can collect all the queries through query store, save it in the query store, and once we know that we collect all the information, almost all the information and all the queries, then go ahead and switch to the new compatibility mode, and then see how queries are reacting, like how they are running. Because the query store is actually turned on and we collected the data, which is a baseline from the old system, just like from the old system. Now, if you have certain, like any hiccups or any queries that are not running properly, you have the space where you can go ahead and nicely compare. Okay, my query sucks right now after the upgrade. What's going on? It should not run this way, right? It should be running fine. It was running fine previously. So now you have the platform where you can neatly go ahead and see, hey, this was my execution plan which worked. Now what is the difference? You can go ahead and compare the difference and then decide if you want to force the last plan until you solve the actual problem, whether it is a cardinality estimate problem or whether something else is going on the new server. You can go ahead and dig into it later, but you do not have to wait, right? You have the ability to force the last good plan. So that's one of the scenario I used. And automatic plan correction and query store hints, which we are going to talk very soon in the demos. But let's see like what this upgrade scenario can do in a in a diagram format. So upgrade to the latest SQL Server and keep the source database at the same compatibility level, and then enable the query store. Wait to collect all the data on your workload, create a baseline, that will create a baseline, right? And then set the compatibility level to the latest compatibility mode, and then go ahead and quickly fix the regressions by forcing the last good plan. Automatic correction. Let's skim through these slides very quickly. There are just two more slides that I'll show before coming back to the slides again and see the demo. But automatic plan correction is like a next level. It's an elite level to the plan forcing, because if you force a plan, right, it is a burden definitely to the DBA to go ahead and see and check and know how many queries did I force, and then we need to check constantly to see whether that plan is still a good plan, or whether something else got generated, some other plan got generated, and it is even more good because the data is changing. You are inserting a lot of data. It's an active system, right? So um, maybe you need to create another index, or maybe you already created and it generated a new plan, and that plan is too good now, but you forced an old plan. Now you need to monitor what is the good plan. This is a good plan. Now you need to unforce and force it. But with the automatic plan correction, if you are in the enterprise edition of SQL Server, and if you are in 2017, hopefully 2017 and above, you can take the advantage of automatic plan correction, which will continuously monitor the last good plan automatically for you. You do not have to monitor. It will automatically adapt, check, verify, learn the information, and it will continuously see and make sure the last good plan is always forced. Now, if you have a good plan, but the next plan that got generated is worst, it will make sure it is it won't unforce that plan because there is a new plan that got generated. Because the new plan that got generated is worse than already existing plan that is being forced, it will make sure it will keep that plan. And if at all there is a better plan that got generated, it will unforce and force the good plan. So that is how the automatic plan correction works, and monitor so that you do not have to monitor. Query store hints is also an advantage if you are in the latest editions of SQL Server. This is an advancement to SQL Server 2022. So, what is query store hints, right? If you know and familiar with the query hints, we generally use the query hints within the query that we are running. Like, for example, you have a parameter sensitive problem, and um, that parameters are usually generating plans each time you run, and it is causing a headache, right? You need to make sure you are having a execution plan which is in place for almost most of your parameters. Like, here and there, if you're having outliers, that is fine, but once you create a store procedure, the first execution, if it is a bad parameter, then that, for example, that parameter value have to do the clustered index scan on your entire table, which have billions of records. That's not a good thing if your parameter, if there is one or two parameters like that, and unfortunately the first time you run with that parameter, it generated clustered index scan, and the next time you run, it is always using clustered index scan just to pull 2000, 3000 records, which doesn't make any sense, right? So in that case, if you are using query hints, then you need to manually go ahead and recompile. And there are several other query hints that you can use, but I'm taking an example of recompile here. You need to recompile and change the code, which is not always the case and acceptable scenario. When you are in the production environments, you need to get lot of approvals. If you have vendors, there might be picky vendors who are not at all agreeing to it. So there is a problem over there. But with the query store, you do not have to touch the code in it. There are specially designed store procedures that you can use with the query store hints. All you need to know is the query ID of your query and what hint you want to use. That's all you need to know. And by using these query store hints, you can use those hints without even touching the code. So there are some hints that I placed here, but to get the complete list of what hints are actually can be used with the query store hints, you can um, you can see the Microsoft links. I will be placing in my demo, so you can see there. But then for now, I mentioned here as max stop, recompile, max minimum, memory grant. You can even choose the memory grant size you want, compatibility level. You can change those sort of things. Now, let's go ahead and see the demo. Let me share my screen. Adriano, are you able to see my screen? Can you confirm if you are available? Um,
Yes, I can.
Thank you. So here I would like to show you how to configure the query store and talking through and walking you through how to configure it properly. So here I'm using Adventure Work, not sorry, Stack Overflow 2013. Um, Let me see. Where is my Stack Overflow? Yeah, it's in SQL Server 2022. So the operation mode are like read write, read only. If you see like um, the properties of the database, and then query store, and then there are modes here, right? Read only, read write, and off. If you turn it off, nothing will happen. It's just like query store is not enabled. Read only is to just the read the information. It will also read if you forced any plans, it can read that information and apply, but it can't write any new information to the query store. But with the read write, it will read the information. If you forced any plans, it can also read that and apply that to your queries, but at the same time, it will write the information as well. You can see the query store data that is available, like space available, all sort of information here. But then if you see, there are also the other modes, um, query query store capture mode. In the older versions of SQL Server, the query store capture mode is all by default. But for the newer versions of SQL Server, I believe it is from 2019, they changed to auto as a default. So go ahead and see if you are using all as your default value for your older versions of SQL Server 2016 and 17. Please go ahead and change that to auto, because once you choose auto, there is internal algorithms set in place which Microsoft didn't release. But based upon how many times the query runs, based upon how much CPU threshold it have to hit to enter into that query store, that is all internally decided by Microsoft. But it will filter out all the insignificant queries that you are not even bothered about. So just go ahead and change that to auto if you're on older versions of SQL Server, right? And none will not capture anything. And um, custom is where you can actually customize what sort of queries you wanted to execute, like how many times a query have to run or how much CPU threshold it have to hit to enter into the query store. You can also choose that. Now, size based cleanup mode is also auto. There is off option here. I would highly suggest not to put that off, because it will not clear up the old data if you put it off. And if you put it off, it will continuously capture, and it will fill up the entire query store, and your query store will go into the read only mode without your notice. So you do not want that. So go ahead and put it in the auto, so that once the space of the query store is reached 90%, it will go ahead and clean up the query store until it reaches the 80%. So you still have 20%, and query store will not go to the read only mode. So auto is the one which we want here, right? Stale threshold query, stale threshold days is like 30 days by default. You can change that as you want, but after hitting 30 days, it will go ahead and clear out the old unused information within the query store. It will automatically clear that for you. It will not clear any forced plans. It will not clear the any active information. It will only clear out the oldest unused data. Wait stats capture mode is it is turned on by I think it's from 2017. Wait stats mode should always be turned on to capture the wait stats information, and you can capture like execution count, how many times a query have to execute, um, like what is the threshold you want, and all sort of that information here. Most of them we spoke here, so I'll close this one. And then one more thing is like flush out intervals. Like I said, here it is 50 minutes. I have changed, but it is like every 15 minutes it will clear out the memory. Inside the memory, the collected data is pushed to disk. Statistics collection information collection interval is 15 minutes. So something to remember here is every 15 minutes, no matter how many times your query runs, it will only have one record in that particular interval, just so it won't blow up the query store, right? No matter how many times it runs, it will capture the average values, and it will show you the average values. So that's all the information, and the same information that we discussed in the about all of these options is also placed here. So I will go ahead and execute this one, and I gave all of that information that I have spoke here as a notes I have placed here. So to see what is the um, why did I even place this one here? I just want, maybe I want to see the query store options here. So I'll execute this. This is a view where you can actually grab the information on where you enable and what you enable in the by retrieving the views, query store views, all the information that you have chosen, right? The size, and then intervals, and like what are the threshold days, size based, cleanup mode, everything. And then where did I place this in here? It's been a while. I don't even remember why I placed it this query here. But let's see. Oh, I wanted to show you like how it will collect the information and how it will show the information using the view. So the query text ID you will see, and if you see here, mm, query text ID, query ID, and you will also have the plan ID here. Um, So, and then you would like to also see, you can also filter out by using the query text here to pull up that query ID, right? But if you see here, if I expand query store, let's see top resource consuming queries, view top resource consuming queries. I didn't run much queries, but I would like to just show you how it will actually show this query text and everything. So this is the query text that is being executed since long time. But if you hover your mouse over here, it will show you, it will not show you the parameter values. It will show any query that you are running, like store procedure, let's say. It will show not the text of the store procedure, but it will show you like a parameterized format. It will not show you what parameter it being used. So now let's go to we have discussed like the configuration options here. And now let's go to see how I have upgrade, how I have used it. Could not find. Why I could not find. Let me see. Hmm, upgrade scenario. Maybe I'll open it here. Hmm. Oh, it opened a different one. Okay. Nope. I just want to copy this one and use it there. I just need one window to be opened here. So we are using which were wide world importers database. And do I have it? Yeah, it's in here. Wide world importers data warehouse database. So that's on a different server. I have couple of instances installed here. So let's connect to that and see the databases. Yeah, it's here. So we are using a different server. Let me connect to that server and show you how I actually used um, in my upgrade scenario. So I'm using AdventureWorks data warehouse database here, which I wanted to let's say I migrated it, right? This is a 2019 database. I migrated from old version to new version. Now what I'll do is I'll free up the cache in here, and then I'll place the database um, in the read write mode after the upgrade, right? This is a new version. Now what I'll do, I will enable it with all the options, that configuration options that we choose, and then let's put the database in the old compatibility mode, which is 110. This I migrated and then I placed it 110 mode. Now what I'll do, Let's say the store procedure is already there in the older version, but here for my demo, I'm recreating it. So all I'm doing is selecting, doing some joins between two tables, and then I'm searching on the where clause. Very simple. I'm running this particular store procedure, recreating the store procedure, and then I'll clear out my query store. Do not do this in production. It will clear out your query store. I am doing free proc cache as well. This is my demo again. I want my demos to work. So I'm running that. Don't run that in production. So um, so let's say there is one store procedure that we just created. I'm running it with this parameter 360. Let's go ahead and execute. Again, if you remember, we are executing this in the older compatibility mode, right? We migrated and then we are doing older compatibility mode. Now, if you see here, query store, top resource consuming queries. All right, I would like to see it in the grid view format here. Okay, now it generated one plan ID. If you see clustered index and column store index. All right, now I'll go ahead and change it to 130 level, which is the latest compatibility mode. Let's say we collected all of our queries. In my demo, I'm just showing you one query. Now I'll go ahead and execute this particular store procedure again and see how it will react, refresh, and see the difference, right? Now, the first one, if you hover your mouse, it says like it took total duration of 46.66 milliseconds, and second one is working fine. Total duration is 8.61 milliseconds. Now, instead of seeing the duration, if you see the CPU time is also good. Like you can see all the values here. Even in the CPU time, it took like total CPU time 8.61. The second one, the second execution. The first plan took 40.29. Now, this is what we would like to see whenever we are migrating the database from older to newer versions. Now, here my query executed fine because it is a new environment, but not all the queries are like this, right? You can see it in a reverse. Now, the older one is number one, which was like it is working better than before. Now, I can clearly see the difference. And then you can compare by clicking the shift and then select both of them. And then here is a compare button over here, compare the plans. And once you click on that, right, did you see like a equal to sign and there is a cross line in between? That is like, that is an indication of what are different. And if they are not mentioned, that means they both are same. So you can see all the difference here. And then you can also see the difference in the execution plan clearly. And if the old plan is good, you can just go ahead and push the old plan. But most of the time when you migrate queries, like I showed in my example, it will work fine. But this is how I created a baseline. I had my previous value here, previous plan here, how it used to work in the older compatibility mode, so that I can take advantage. I can build the baseline. So that's how we do the baselines while doing the database migrations. Let's go ahead and see the third one. Uh, let's see the query. I don't know why these things are not opening up, but let's see if I can get this one. Query store hints, which I would like to show you in the by using Azure SQL database. Now let's connect to Azure SQL database. Let's connect to Azure SQL database here. All right, and here we connected to Azure SQL database, AdventureWorks, right? So here, let's see what I have to do here is like, I would like to show you an example of how we use the query hints regularly without query store. Whenever we want to use a query hint, we just use the option here within the query itself and then give the hint, use hint option and just provide what hint you wanted to use. That's a regular one, regular hint. But then with the query hint, I would like to execute the same store procedure, very simple store procedure. It's like pulling couple of records from a table where product ID is searching on a product ID. Um, and then I'm executing within the database adventure works. This is an advantage. This is an advantage on SQL Server 2022 and in Azure. So first they introduced in Azure query store hints, and then they also introduced that one in SQL Server 2022. Um, my database um, is in sleep mode. The Azure SQL database. Maybe that is the reason why it is taking a lot of time to pull the database here. Um, hmm, I think I have to increase the tier. I'm using the basic tier. It's a demo. It should be free. I signed up for free, so I think I have enough credits to expand as well. But yeah, I have to see. I have to upgrade it. So let's execute this one. Now we have a store procedure, right? Now I created a store procedure. So the first time I run should be a good parameter, right? Let's see. I'm clearing out my query store and I'm clearing out my procedure cache here. Okay. Now I'm executing it twice. Um, so I hope you're. I hope you are able to hear me. So I am going to execute 870 and 942 parameters, which are very sensitive. So let's execute that with the actual execution plan on to show you how it have actually pulled the pulled the query. Um, the results, if you see, the first execution is 360,000 records and second execution is 385 records. Did you see the difference? The first one is a parameter sensitive. It's a outlier kind of thing. Most of my parameters gives like a couple of hundreds of records, but this parameter will give me like 360,000 records, right? So the first time I executed with that sensitive parameter, which produced 360,000 records, it did clustered index scan, which is good. But then is it really necessary to do the same clustered index scan for that 385 records? This is the general scenario. This is how it uses, because that's how query engine works. The first time that you put a query plan into the cache, it will go ahead and use the same plan from the cache, and then it will use that. But here, with that very less amount of records, we don't want that. But usually, if we do not have query store, we just do like recompile and all sort of things inside the store procedure, that sort of thing. But with the query store, you can use this view to get that query ID for this particular store procedure by using the query text itself and get that query ID, right? Query ID 1. Now all you have to do is use execution sp query store set hints query ID 1 with the option recompile. Okay. Now you need to execute that. All you have to know is query ID and the option recompile, and then you are executing that. Right now, let's go ahead and execute the same store procedure and um, see the execution plan. Now, did you observe it did the clustered index scan, which is required for 361,000 records, but then the next one did index seek and seek lookup. This is the best thing for 385 records. We do not have to go ahead and scan the entire table. Clustered in index seek and the key lookup is good. So that's how we did not change any code, right? All we did is query ID and then option. Now, to see what all hints I have enabled on this particular database, you can execute this particular view to see The query hint ID is 2. Now I will tell you why it is hint ID 2 in a minute. But on the query ID 1, we did the recompile. The current query hint that is enabled is recompile, and the current hint ID is 2. But where is my current hint ID? Past hint ID 1. Now SQL engine will not capture that information. Like if you update the query hint, it will update with the current information without saving the old data. So to capture the old data, the history of the query hints that you used to have, you need to run the extended events. And I have written a blog post on that, how to actually generate with code and query and everything in it. Just you can go ahead and um, look into my website dbanuggets.com, and underneath the query hint um, blog series, you will find how to create this extended event to capture this information. But by default, that information is not captured. Now if you wanted to use other hints, you can use the max drop one. But if you update that, it will go ahead and update the entire thing. Now let's go ahead and update this. I have removed that previous hint, recompile, and I did max stop one. Now let's go ahead and clear out the cache and then execute this execution plan. If you see, the previous one gone away, like clustered index scan is in place again because we removed that recompile and then we put max stop one. But if you see the properties in here, it will go ahead and use max stop one for both of them. Actually, max stop one, it will use max stop one here. But what if you want to use multiple query hints, just go ahead and do append instead of override. Option recompile and max stop one, both of them together. Execute that, and then now see, by clearing out the cache, now see the plans. If you see the plan, the clustered index scan, index seek, and key lookup, both of them work together nicely. And if you see the properties, both of them will use the max stop one. So you can actually use multiple hints together. They all work together, right? Now, to see what all hints are there, or like to remove the hints, just give the query ID and then use the store procedure sp query store clear hints will clear out your um, hint for that particular query ID. Now you should go ahead and look what are the current hints. You will not see anything because you cleared it out. Now to see the active query hints that you can use, please go ahead and visit this our website. Now let's go ahead and continue my slides. Oops, did I go? Okay, now maybe I have to scroll down to see. All right, here we are. Okay, query store advancements in SQL Server 2022. So in SQL Server 2022, query store is enabled by default, and also it have the ability to capture the data, query store data in the secondary replica. Now it will capture the data from the secondary replica, but it will send over that captured data to the primary replica, and it will save on the primary replica database because secondary replica is read only, right? And this is still in preview mode. It is not publicly available yet. And then query store hints that we talked about in the demo, that is an advancement in SQL Server 2022 as well. And all of these intelligent query processing features that are listed here will use query, query store, memory grant feedback, degree of parallelism feedback, cardinality estimate feedback, and optimized plan forcing. All of this require IQP features, right? Um, and the highlights of these IQP features, there is no changes that you need to make, only that you need to change the compatibility mode of the database to 2022, which is I know it's a very big thing to change, right? Especially when you are migrating from the lower versions to the higher versions. changing the compatibility mode and taking the advantage of all the new features. You don't know how it will work, but then you can shift back and forth and see how it will work. But to take the advantage of IQP features, you have to change the compatibility mode of the database to 2022. They can work together. It's not like if one IQP feature is working, the others will be in sleep. It's not like that. They can work together. Query store for secondary replicas, like I mentioned, no matter how many read-only replicas you have, and if you wanted to capture the query store information on all of these read-only replicas, you need to enable that on the primary replica and mention which read-only replica you want to capture that information. And once you capture, it will send back the data to the primary read-write replica, and it will save there. And this process will use the same exact methodology and the same pipeline that it uses to send the data from the read write replica to the read only. It's like for the always on what um, way it uses to send the data, it will use the same channel to send back the data to the primary read write replica. And you need to enable trace flag 12606 to make this possible. And you can also query the data visible by role type, like if you want to see the data for only um, for which for which secondary, by mentioning the secondary name you can do that. But for now it is in the preview mode. It's not for the production. It's for the lower environments only. And how do you enable it? Like I mentioned, you need to first make sure query store is actually enabled on the primary replica. You need to make sure that, and read write mode, and then connect to the primary replica and run on each desired database. You need to alter the database for secondary, set query store on, and operation mode read write, so that it will start capturing the data on the secondary database. To disable, connect to the primary and run on each desired database. Alter database name, set secondary, set query store off. That will turn off for the secondary database. But how do you force and unforce a plan on the secondary? Now, how you need to make sure like each secondary, you know which one you are changing, right? So here, the first one, like for example, you just have like two to force or unforce plan on the single node SQL Server. All you need to know is like I query ID and the plan ID. But for the primary data, if you are using the always on availability group, you need to know three parameters. One is the query ID, another one is the plan ID, and the third one is on which on which uh, uh, on which replica you want to make this change. There are three values in here: 0, 1, and 2. 0 means it will force on read write replica only by default, which is a primary. 1 meaning force or unforce on all read only replicas, and 2 will force or unforce on all the replicas, including primary. So if you're having an ad hoc problem, right? Too many ad hoc queries filling up your query store, you don't want that, right? In that case, you can delete the ad hoc queries by clicking on this link. It will take you to the Microsoft Docs. You copy that code, create a agent job on the SQL Server, and run it frequently, so that it will go ahead and just delete those ad hoc queries for you, so that you do not have to, like, your query store doesn't have to go to the read only mode, or it doesn't have to clean up the data all the time. Now, the best practices, some of them that you need to definitely remember are: avoid a drop and create pattern for containing objects. Like for example, if you are dropping and recreating a store procedure, then that will change the query ID, and all the information that you grabbed inside the query store related to that old query ID is now can't relate to your query ID of your new store procedure, right? The same code, but a new query ID. You just can't go ahead and look, or like you just can't go ahead and force any of that. information will be irrelevant because the query ID have changed. So if you want to change the stored procedure, if you force a plan, or like if you want to change a code, once you enable the query store on the database, instead of dropping and recreating, just to alter so that you will have the same query ID. Avoid renaming databases for queries with forced plans, because that will actually fail. The forced plans will fail if you are rename the database. Of course, you won't do that often, especially on production, right? You won't do that, but I'm just putting it out there so that so you know. And enable the trace flag 7745 to avoid writing query store data to disk before SQL Server shutdown. So before like i- once you enable the query store, it will start collecting the data into the memory, right? And then upon the intervals, it will go ahead and flush that information to disk. Now, if you want to shut down for any number of reasons, while shutting the SQL Server down, all the collected data inside the memory will have to first flush to the disk before shutting down. Now, depending upon the amount of data related to query store inside your memory, it takes that much of time. So if you do not want that, and if you want to quickly restart and enable all your production databases, then enable trace flag 7745 so that it will it will try to restart your SQL Server very quickly. At the same time, you need to be okay to lose that data, right? That particular interval data, you should be okay to lose, because if you don't want to lose, then you need to wait for more amount of time for your server to restart, because this information should be flushed to disk first and then restart. So use that query trace flag, and then trace flag 7752 is while you restart. The first one is while shutting down, the second one is to restart. Now, when you are restarting the SQL Server, all the databases needs to come online. But if you have query store, some of the system information related to query store have to be pushed into the memory before the database comes online. So what you can do is trace flag 7752. You can enable that, which is by default turned on queries on SQL Server 2019 and above. So you can comfortably go ahead and turn on any of the lower environments, like in lower editions of SQL Server, because it's already enabled by default on 2019. So by enabling trace flag 7752, you will start your databases very quickly. But then once you start your databases, then it will go ahead and slowly push that query store information into the memory. But what will happen is, like, your database will be turned on, but then as your as your system information is being pushed into the memory related to query store, the query store have to be in the read only mode for until it gets the data into the memory. Now, this is an advantage because query store information is not that important, where you have to sacrifice your database being not available on production, right? Your database needs to be available online first and then collect the data. So use that 7752. Some of the things to remember are, like, any query hints in your code will override your query hints. So um, your query store query hints will override your query hints. If you have any query hints, those will be neglected. So make sure you know that. And query store query hints are persisted even upon the restart. Table hints are not supported currently, and like override hard coded statement level hints and plat guide hints. It will override all of that. And if any underlying schema changes, the automatic plan correction will unforce the plan. So you need to make sure what is being changed inside your schema. Like, um, if you're changing the name of your index, or like if you're changing the schema within the index, that will change the objects within your execution plan. So you need to make sure about that as well. And these are the resources that I used to prepare my presentation. And I would like to really thank each one of you for being patient and for listening to this session. till the end. And I would like to thank Adriano for giving me this opportunity to present for our own user group. I hope I did not disappoint. Thank you. So you can follow these resources, and if you want to contact me later, you can have these details. So I hope you enjoyed the session, and thank you so much once again. Adriano, are you there? How do I stop sharing? Remove, and should I remove or like? Um, I see. Thank you. I have a quick question. Jim Barney says, um, thank you. And Jim, you can contact me on LinkedIn if you have any questions because I have to jump in. I'm on call, so I have to jump in quick to my office. So thank you so much, everyone, for attending. And yeah, see you all again. Bye.